Now let's have the other interworking practice with Hyunso, and this is oneM2M to Zigbee interworking. So as a motivation, there are three kind of topics that we're going to kind of cover in this session. The first thing is Zigbee, and we chose Zigbee because this is still kind of abundant in home IoT. It is still widely used in deployments. And the other thing is the TS0023 Home Appliances Information Model as the oneM2M standard. And with the Zigbee interworking, we can use the data models from TS23. And the latest version of TS23 is based on the SDT, which is Smart Device Template in oneM2M specification. So we can show how do we use that template or the concept with the home appliances data model with the Zigbee devices. And from the oneM2M API standpoint, we've been using many different resource types and the resource APIs. And in this session, we are going to use the flex container, which is different from the ordinary container and content instance. So in this interworking tutorial, not just the interworking, but we are going to cover different topics. In this tutorial, we will really quickly explain what is Zigbee, because everyone knows Zigbee and you can get all the information from Google, I think. And then the main part is explaining SDT and the LoRa IP architecture and the simple system that we are going to build up. And as a demo, we will have the Zigbee gateway and devices, and we will show you how that Zigbee gateway is working with the Zigbee IP that we are providing, of course with the oneM2M platform modules today. So in this session again, we are going to show you how Zigbee interworking is done, and the data model for the Zigbee devices are mapped with the home domain information model from TS23, as well as the smart device template. For the Zigbee gateway, to get the data or to push the data down to the Zigbee devices, we use a software implementation named Deacons. And for the Zigbee IPE, we provide the source code from our GitHub repository. And for the hardware itself, we use the Raspberry Pi 3. And for the gateway module that we will plug into the Raspberry Pi, we use Combi 2 and some Xiaomi Zigbee devices that you're going to see soon. So what is Zigbee? So this is the information from the wiki, and explaining Zigbee is not the point of this tutorial, so we will just skip it over. And Zigbee is low power and low energy latency, and that is still kind of reliable, and the benefit of the Zigbee is really cheap and simple. And before we talk about the Zigbee interworking and how it works in detail, again the SDT needs to be kind of explained at this moment. And SDT again represents the smart device template, and the device template means when you have defined a data model, when you represent a device into the oneM2M or oneM2M platform, this is the template. The template means there will be the device level, and of course there is some information regarding the device, and the thing is basically there's a device and there are different module classes which consist of different devices. For example, the fridge has the switch, for example, and the door, and the TV has a switch, and in the remote control there's the volume or the channel, or and so on and so on. So model classes are kind of defined to be used in different device types because there are common kind of module classes like the power or the channel volume as I explained. So this is all about the home appliances modularization, and not just the home appliances, but it could be used in different kind of domains. This is the kind of diagram from TS23 and domain, for example, the home domain or the other domains. And in this section, what we really care about is the device and then the module classes. And in module classes, we have data point and action and event, which consists the functional module. And we are going to kind of map the device and the module classes into the flex container resource types. That's why we're kind of trying the other APIs other than container and content instance in this session. So this is the architecture, and from the left there are Zigbee devices, and some are sensors which report sensor measuring, and there are several actuators like the light bulb. When we send the command, then it gets turned on or turned off. And there's a Zigbee gateway, and then the IP that we are providing from the GitHub, and then finally the oneM2M platform. In this case, of course, the Mobius. So this is the system deployment, and from the left there are Zigbee devices, and devices are consist with the device classes that we saw from the SDT concept, and we will see the individual classes really soon. And they are connected with the Zigbee device, and in the Zigbee device the board itself is a Raspberry Pi, and we will put the Zigbee dongle, and to work with those hardwares we use Deacons as the software for the gateway. There's the Zigbee IP that we provide, and this is the code implementation itself at the moment is based on the Deacons the APIs, because this one provides the REST APIs. So to work with this setup, you will need the Zigbee devices which are compatible with the Deacons. And as a list, there you can find if a device is working with Deacons or not. You can check it from the Deacons website. So this is the resource tree on the left hand side. So in the CSC base, there's the Zigbee IPE as the AE resource, and under that AE resource we represent 3 different devices. And in this tutorial we use door lamp and the thermometer and the light. And on the right, this is the JSON representation of the different flex container resource, and of course the flex container has the other common or universal attributes, not just 2 like this, but those are just for information. I think the CND, which stands for container definition, is really important because this is the indicator what kind of specialization of the flex container is for this container. And this is, for example, the oneM2M home device as the DORA, and for the device representation in flex container, we use the flex container in the object. And for the thermometer, we use different container definition, and for the device light, we use the other container definition to distinguish this is the light defined by TS23, which is home domain information model. And you can note that there is no special custom attributes. And what I mean is can be noted like here. For example, this is the module class for door lock and the battery, and the door lock has the lock as the property, which is additional to the container definition. But if we go back to the device, like the door lock and the thermometer light, there's no other custom attributes like that. And this is what has been defined in TS23 regarding flash container resource mapping. So anyways, as a summary, we will create the three flash containers which represents the devices individually. And in the Dora has two different module classes, Dora and then the battery. So we saw the Dora, and for the battery, there's the battery level, for example 0 to 100. And for the thermometer, there are two different modules. One is the temperature and the other is battery. So this shows that the SDT is the modularization, which can be reused within different devices, like the thermometer has battery and the Dora has battery. So this is the modularization that SDT is aiming for. The temperature has the current temperature. And lastly, the light has many modules like the binary switch for the actuation and fault detection, color saturation, color brightness, and so on. And each module class defines many data points, or some are the action points, but these are just kind of couple of properties that we chose for the implementation. So for example, binary switch can be represented in JSON like this. The container definition is the binary switch as the module class, and it has the power state and the other. So let's see the simple scenario with all the actors. We have the Zigbee light bar and Zigbee binary switch and Zigbee gateway on top of Raspberry Pi and the oneM2M platform, and in between there's the Zigbee IP that we provide. So the simple scenario is, of course, the IPE registers as the AE to the oneM2M platform. And in the meantime, Zigbee devices can post their sensor status, like bulb is on or switch is on, for example. And the Zigbee IP, it send a request to the Zigbee gateway. In our case, there's a Deacon's REST API, so we use that one in this request, and there is the response coming back to the IPE, and IP parse the data and send it to the oneM2M platform. And updating sensor status would be the first container update, because in the initial stage, not only the AE creation, but the sensors are created as the flash container and the module classes. And we, in step 5, we update the created flash containers, especially the module classes. And the other scenario also we have is some actuation. So this actuation message has been kind of arrived from the other oneM2M application, which is not shown in the diagram. and of course it should be another flex container update. And when the flex container is updated in terms of the device actuation message, and it will be sent to the notification to the IPE. That means IPE creates the subscription beforehand, and due to that subscription it will get the flex container update, and it will kind of parse the information and target the right Zigbee device and send the device actuation to the gateway. And again, this is the Decon's API, which we can send the device actuation message, and it will go to the right target, and the actuation message will be arrived on the Zigbee device. For the gateway installation, you can follow the instruction like this and this. There would be no problem as we did locally. And install the decons. And after the installation, you will see that from the menu and kind of run it. And the first thing we need to do is click on the connect button to make it kind of activated. Then we can proceed with the device connection and so on and so on. So as we said, after a few seconds, you will see the connect button gets activated, and then you will just push the button. Later, you can access to the admin portal over the on the web browser, and from this slide, we will skip the instruction slide by slide, but we will provide you the recording after the presentation, so you can check it by yourself. In the menu and the devices and sensors menu, let's add some sensors, because we just gonna run the gateway and we have several sensors and they should be registered or connected to the gateway. And add your sensor and choose some type, and please follow the instruction that we're going to show you after the presentation. And we see the connected sensor, and we need the gateway's API key to use the APIs provided by the decons, and this is the instruction how to get it. To get the API key of the gateway, you send the request to this URL with the pulse with this body. Then you will get the key like this in the response body. And to see the list of the sensors that are registered to the gateway, we can do that. We can check it from the admin portal, but we can also do that by the REST API they provide. And the numbers are the sensor IDs for these decons. And here are the kind of properties. We can also check the individual sensors status, like the battery level inside the config or the other properties inside the state. Like this is the door lock, and we can check the status if it is open or not, like this from their API. And again, from the previous API of the decons, this is listing all the sensors and their information. And this is decons, and lights are in different URL, unlike the sensors. So for the lights, you should can use this URL. And for example, in this sample, we have two lights. To control the light, we still use the lights in the URL, and we put the light ID And since the controllable properties are in the state property, like here, so we put the key value for this state, and you will indicate the state in the URL and send the put request, and having a body like I want to change the property name on as true. So on could be true or false. Just for your information, if you really are interested in state only other than the other one, there's no kind of resource URL accessible by Deacon, so you should just use the light ID in the request. So this is the interworking procedure and actually the setup. So download the source code from the GitHub, and for your own setting, you should change some configuration. And just like the LoRa IPE, we have our own devices, and you should reflect the Zigbee sensor IDs, which is given by the deacons, and put it to the source code, and then run it. So this is the repository again, so you can get the zip file or you can clone the repository. And in the conf.json of the project, you can change the oneM2M platform setting. In this example, we use the local Mobius. And as we saw how to get the Zigbee Gateway API key, you should generate it, and you should put it like here for your own setting. And the sensor is from the Postman script execution before, we can get it the same information, or we also provide the API call with the sensor list.js, so you can just execute that one. So there are sensor ID and the information, and mostly the interested information is in the state property value. In the app.js and the Zigbee IP.js, there is the mapping between the sensor ID of the deacons, like 234, like this, and then the properties of those devices, like the sensor 2 has the temperature, sensor 3 has the humidity, sensor 4 has the pressure. So this is a mapping in one way, and the other way of the mapping is written here. And this is a really simple LoRa IP source code that we provide, and you can change the logic later once you understand how to use the deacons and oneM2M APIs. And when you get it, and of course, just like the other older sample codes, you will install all the modules dependent, and then run it with the node app.js. So once you run the Zigbee IPE, then you can check the resources by the Postman, for example. Like the IP itself created the AE resource for itself, and under the AE, as we saw from the resource tree before, there will be the flash containers representing different devices like the DORA or the temperature sensor. And for example, this is the device light that we created by the IPE. Content definition says this is the device light. And under that device, we also can retrieve the module class, for example, color. And the color, we have red, green, blue as the custom attributes. And whenever there is new sensor reading from Zigbee devices, it will post data to the deacons, and LoRa IPE gets data from the deacons and convert it and send the flash container updates to the oneM2M platform, because flash containers are basically the resource that is updated to have the new sensor measurements. And after this, we will show you the demo with the configuration on the Deacon setup. And also we will show you how your Zigbee devices are working with the IPE in the video. Thank you. Well, I forgot to mention it. In the demonstration video, we will also show you how the actuation from the other monitor applications are sent to the Zigbee device in the end, and some physical device actuation will be demonstrated. Thank you.